Hello guys, and hope doing well. 100% some guys will try to connect the oscilloscope to the AC 220 volt power outlet or any USB output to check the AC power on the oscilloscope. So the companies that they are made UPS or power lines or something, and 100% as soon as you connect the oscilloscope to the AC power, it will disconnect the power input, and you should turn on the fuse again. For the UPS, will make a small explosion or something, but the solution to check the AC frequency on the oscilloscope is this device. The name is Differential Pro. So it's coming with one BNC connector as output. It's able to connect to the oscilloscope. I change with this Pro, so I take out this Pro from my oscilloscope and connect this one as the oscilloscope input. So you can see I'm connecting to the frequency counter I'm using. And also it's needs for batteries, and also it's able to connect to the DC adapter to use it by DC adapter, but I highly recommend to use the battery because of when we are going to use a different AC source, is much better to use as battery. So I will close the battery door. So I have two option, 1 and 10 and 1 divide 100. It's dependent to the power source, for example 110 or 220 may show on your oscilloscope scale higher, then you can change it to have it without changing the scale. So this is two inputs. You can see one of the probes I changed with the this kind of clips, and this one coming exactly originally by this. You can cut it and change with your own nano clip or any other hanging clip. So to review, we should know we are not able to connect the oscilloscope probe like this directly to the AC 220 or 110 power supply. Is very dangerous, will make problem for oscilloscope or the fuse box, and in case of using any other AC source, we do not have exact result on the oscilloscope. So we are using to use differential probe, and this is the company name is BI, and the part number is SI-9000. Okay, so at first I'm going to find the positive line, is this one. You can see I plug exactly the positive to the positive line and negative to the negative one, and I'm going to turn on the Pro. So it's very safe, and the output is connected to the my frequency counter. So my frequency is 101 and it's not stable. The reason is my incoming AC power source is connected to the power line to use internet over lines, and a lot of units on my building using this power line, and I don't have a stable frequency here. For yours should be 100% 50 Hertz to 60 Hertz depending to the power company and your country. I'm in Austria and it will stay on 50 Hertz. Also, the thing you may know, because of I'm sure a lot of guys don't have these probes because of I'm sure that just the companies will going for this probe that they are working for the high power voltage. So when I take out the BNC connector and connect it to the multimeter, you can see the output is 5 volts. So it will change exactly the power to the 5 volt to make it safe, but will keep exactly the source input line frequency. For example, it is a 5 volt AC, but the frequencies and any other items is exactly same the power line that we have at entrance. You can see we have fixed at 5.57 or 58. So it's 100% safe to use it. Well, I'm going to connect to this multimeter to the Hertz calculation. It's really simple multimeter, but I'm connecting to the probe. The thing that we should know is if we find two differential probes will work much better. You can see I have 49.96 Hertz and it's stable. When you connect this BNC cable as this probe to the oscilloscope, 100% you're able to analyze the 220 or 110 volt transformers, UPS, and any other high voltage power source, and this probe will support exactly 1000 volt DC or 700 volt AC. If you are not going to change your scale at the oscilloscope, you can change the 100 times or 10 times smaller on your scale, and the power button also located. Thanks for watching and take care when you are working with 220 AC voltage.